Okay, I'm starting. Because we're going to go way back. We're going to go way back in the day. And we are going to go back to elementary school. Remember that stuff? Do you remember doing long division? You did do it. Are you pretending you didn't? Okay. Hey, Danica, I have a skill testing question for you. When you divide, what's the result called?
A quotient. I know, but I just wanted to say it anyways. A quotient. Period.
We just had this conversation the other day. Okay. So let's break down the parts of this. So we have the thing being divided into, so the number of groups that you're making, that's called a divisor. The thing being broken into groups is the dividend. Everybody with me? Okay. So do you remember how to long school, old school, long divide?
Yeah. I used to do this in elementary school and now I don't remember it.
Okay. So what do we do first? We draw the pretty picture.
What?
We draw the pretty this. We put it in long school, old school division, long division, right?
Okay, yeah.
So we check to see if 3 can go into 1. Can we break the 1 down into 3 groups? No, we can't. So we're going to go over to the 14. So now we're going to the second place. How many times does 3 break down 14? 4 and then some. So we know that 4 groups of 3 give us 12. And then what do we do with those numbers? Subtract them and we're left with 2. Now we check to see if 3 can go into 2. Does it go into 2? No. So if we were in elementary school, we'd stop here. We'd say 4 with a remainder of 2. And then eventually you put some decimal points in there and you added some zeros and you did that sort of stuff. So we can do this with polynomials. I used to teach the long dividing way with polynomials. And then I realized that you guys don't have as much fun with it as I do, and it's not really required. So what I'm going to teach you guys how to do is it's called synthetic division, which is today's what we're working on. So we're going to take long division. We're going to take this division of polynomials, and we're not going to do it the long way. We're going to do it the short way. And synthetic, so it's not like true long division. It's like manufactured, not real, not organic. So it's like the quick way to do it. But you got to remember the rules. Okay? You ready for the rules? This is your divisor. And this is your dividend. Okay? What? The whole thing, sorry. Okay, we good? So we're just labeling the parts. Not a big deal yet. So there's 2 ways to do it. I'm going to teach you the way that I like the best. Because I get to pick the ways. Because that's my job. So for this method, you have to solve the divisor. Super easy, set it equal to 0. Okay? So we're going to take the divisor, we're going to set it equal to 0, and we're going to solve it. That's exciting, right? Okay? Super easy. It won't be more complicated than that. Okay, so then what you're going to do is you're going to take the thing that you solved, and it's going to go outside. Just like the divisor goes outside of the old school division sign. Okay? But this time, we're going to flip that thing upside down. These are the coefficients, because remember it's like 3, and then it's that. So now we're going to flip it upside down. We're going to make an L kind of thing. These are the coefficients from the dividend. And I got to tell you, they need to be in order. Descending order of exponents. And all exponents must be represented. So maybe we need to make a note about that somewhere. Okay, so that's kind of like a rule for the dividend. All exponents must be represented, and we'll get into that a little bit more, but they have to be listed in order from largest to smallest. And so that will be the trick that I put on test, quizzes, exam, is I'll list the exponents out of order, and I'll expect you to reorder them. Look, I'm telling you the trick. I'm telling you how I'm going to try to manipulate you. I'm not going to tell you that. I told you that now. I'm pre-telling you that. Okay. You're all going to need a tattoo. All right, so now that you have all that listed, super easy. Step 1, we just carry the first coefficient down. So the 6 gets represented. Super easy. I know, now we can't see it. Oh, right underneath it. The 6 gets carried down. Then you are going to take the divisor and you're going to times it by this. So 2 times 6, what do you get? 12. So that goes right here. That goes right there. The product of those two goes right there. Guys, it's literally long division upside down. I don't even know what to say to that. I'm just going to keep going. Then you add those together. Negative 19 plus 12, what do you get? Negative 7. Good job. Okay, then you're going to go back. You're going to go 2 times negative 7. What do we get? Negative 14. So that goes there. And then you add. Then you put it in the spot. So this is 2. And then you do it one last time. 2 times 2. And that goes here, which is 4. And then... Okay, all right. So when you look at this, these are the coefficients of the quotient, and the farthest right-hand side is the remainder. So this is what I do. I go, okay, that's the remainder, that's the constant, that's the x, that's the x squared. So I have no remainder, so it divides into it evenly, and I would have 6x squared minus 7x plus 2 is my quotient. Guys, this is the easier way. Like, I can teach you how to do it long division, but I think that that's not going to be helpful. This is, like, it's a pattern. Like, once you get going with the pattern, you'll be fine. Okay. Okay. So, let's walk through the first example together. Okay, step 1. Which one is your divisor? X plus 3. Solve it. X equals -3. So if we solve that, it's going to give us -3. So when I draw my L, the number on the outside is going to be -3. Good job, everybody. Proud of you. Are these in order? Are all exponents represented?
No. Because 4 and 2.
4 and then 2, we're missing the cube. It needs to be represented. Okay, so when you put these in, my coefficient on the 4 is 1. How many x cubes do I have? 0. What's my coefficient on the x squared? -10. And then the coefficient on the x? -2. Constant is 4. Okay. We good? So that's the setup. That's all you have to do for the setup. Okay, step 1. Drop the 1. Now, step 2, we are going to take the divisor and multiply it by the 1. What do you get? -3. That goes in the box. Now, what do I do with those two numbers? Add them. So you're going to add those. What do you get? -3. Okay, we ready? So now we're going to go -3 times -3 gives us +9. So that goes in the box. And then we're looking at adding these two, and I'm left with -1. Okay. And then we're going to repeat it again. -3 times -1, +3. That goes in the box. We're going to add these. That's going to be a +1. And then -3 times 1 gives me a -3 for inside the box. And that will give me a +1. So that doesn't look like it's a lot of stuff. But what I want you to do is start on the far right-hand side. And this represents the remainder. This represents the constant. This is your coefficient on your x. This is your coefficient on your x squared. And this is the coefficient on your x cubed. So the quotient of this is x cubed minus 3x squared minus x plus 1 what? And then this is how we're going to write the remainder. Everybody ready? Okay, because it's what's left over. So it's plus 1 over the divisor.
So what I mean.
And you are done.
Oh, no, I skipped ahead. Never mind. I'm very bad.
When you bring it back, it goes away.
Okay, so let's do this. Danica, let's go back to grade 9. It's a little bit closer. Okay, so let's do this. Grade 9, exponent rules. What do we do when they have the same base? We're dividing them. What do we do to the exponents? We subtract. So this would leave me with x squared. So the idea is that when you are dividing, you're dividing them into how many groups you can have, right? So we're saying, and then if you want to do it backwards, we're saying x times by the divisor should give me the dividend. Or sorry, the divisor times by the quotient should go backwards. You guys agree with that statement? This is like, it's really It's not that bad.
This is all of this less than
Yeah.
Wow.
Okay.
Sorry.
So it's always going to be smaller, Janika. You're always going to have one smaller than the original exponent. Always.
But you say this and then every time.
No, I never say always unless I mean it.
That's just what.
When did I say always?
Remember, radicals are like, it'll never be negative.
Until we do, and then I said until we do transformations.
Negative.
Yes, I did. Yeah, I did.
I did
Okay, let's do this one. Which one's my divisor?
X subtract 2.
Okay. So 2.
I'm having fun.
Okay. Okay. So 2 goes on the outside because we solved it. Is it in order? Are all the exponents represented? Yes. So we're going to have 1, 7, negative 3, 4. We're going to bring, yep.
If we had like a polynomial that started at squared, we
Mhm.
would just start at that coefficient.
Yep.
And then there's no cube for like
100%. Yep. You start at,
in the middle.
you have to represent it. Yeah.
What about if it's at the end? Like what we're missing, like a constant.
You need it. You need all of them.
So then you just start.
You start at the highest exponent and you fill in zeros if there's any missing. And constant is constant is included. Like if I don't have a constant, I have to put 0 there.
Okay.
So first step, take the 1 down. Second step, 2 times 1. 2. We're going to add those. 9. What's next? 18. Negative 3 plus 18?
What?
Okay. So to remind myself, remainder, constant, x, x squared. So it's going to be x squared plus 9x plus 15 plus 34 over x minus 2. Because it's like we can't break down that last group. Okay, I'm kind of jumping ahead. No, I'm not going to jump ahead. Never mind. I was going to jump ahead, but I don't. Okay, so that was synthetic division. Now we're actually going to do the remainder theorem. Well, you need to know how to synthetic divide, and you kind of need to know what a remainder is before we do the remainder theorem. Are you looking? What are you doing, Basil?
I was not funny, sorry.
Are you taking pictures of Shiv?
What?
Or the phone?
Wow, it's not
You're supposed to take it at the ceiling, so I don't see you taking a picture.
Oh,
You just...
you know, like,
Okay, fair. All right. Okay, we're learning. Yeah. Okay. All right. Okay. So this, we use this when the question... You put it in your lap and tilt it. Oh, yeah. Okay.
the bottom half of my face is so ugly though. No one needs to see that. Like,
Well, then tilt it like direct. No, tilt it towards your pad. Or the other side.
I'm gonna take pictures of that is content. That's rude.
Are you still taking selfies?
No, he's trying to snap somebody, but without an actual picture. So he's trying to take a picture of like nothingness to send a snap back to somebody, but he's like holding up his camera and taking pictures. So I'm trying to teach him how to do it discreetly. Yeah, I'm recording. This is all in the video.
I have my old mini phone case, so it's pretty hard to like.
True story. I love it. Okay, can we go back to the math? I'm too distracted. Okay, the remainder theorem. We're gonna use the remainder theorem when I ask you to find the remainder. without doing synthetic division. So the first way well, because it's going to get complicated. So the first way is to use synthetic division and actually find like the quotient and the remainder. So you can do it that way, that's fine. So if you, on page 1, you can continue that way. The faster way to do it, if I'm just asking for the remainder, is to solve your divisor, and then you're going to substitute that in as the x value. So then, what we learn from this is if I substitute in -3 everywhere, we're going to learn that what is left here, this is your remainder. Only if my question is asking you for what's the remainder. So, but if I want you, is this a factor, then you're going to have to do the whole thing. But that's a Monday lesson. That's a Monday lesson. Oh, Tuesday, okay? Okay. Yeah.
Are you going to be mad if I don't hand in all my assignments tomorrow?
What's tomorrow? Oh, and it's a 7-8 test, guys. It's got the exponents on it. Yeah. Yeah, I'm not touching the assignments on the long weekend. So it's 7-8. Okay. Why do I need to mark them? We did them as a team. Except for Nicole, she got some correct answers there. I will definitely get them marked.
What is that letter beside your one there? It says blah.
It's an F. Good try, Nicole. Good try.
She don't know. Why is it F?
F of X.
So why?
Not this way, of course, Tanika. Oh my god.
Okay, so all I did was I solved my divisor, and now I'm substituting it in everywhere for I see X to find just the remainder. It's not going to tell me what the quotient is. It's just going to find the remainder.
Are we going to get our calculators for this?
No.
Oh.
Yes.
Yes, we should. Okay.
But then on the exam, no. Like this would be in a non-calculator portion. Like I have the utmost faith that you can square and cube -1s. Yeah.
So for this one, we don't have to fill in our missing exponents?
No. Nope.
I would just do it the long way then. So
So what's -1 cubed? Nope. -1. And then it's times by a -2. So I've got a -1 times by a -2. -1 times -1 is negative, and then times -1 more time goes back to positive.
even exponents are positive and odd exponents are negative.
Okay, we good? So what's the remainder? 0. I'm gonna ruin Monday's lesson. If we have a remainder of 0, okay, see, this is why I'm ruining the lesson. I can do it because we have no lesson. If we have a remainder of 0, this is a factor of this polynomial. But that's Tuesday's lesson, so. What? What? Why? That's Tuesday's lesson in a nutshell, right there. Done.
But it's only a single factor, right?
Factors are two things that are multiplied together to get another big thing. What are the factors of 12? 3 and 4.
But it's only a single factor.
No. Okay, no, just never mind. Okay, do this one, ladies and gentlemen. Do the next one. You're on your own. Nicole, lead the way. Solve the divisor. Nope. Not when you're doing the remainder theorem, you don't. And you don't have to fill in the missing ones.
gonna do math.
Yes.
Yeah, I know, but what's 4 times 81?
Yeah.
324.
Oh, why are you guys cubing stuff in here? Okay. I was like, there's no cubes anywhere in here.
We're quadrupling it?
Yes.
Period, okay.
No, Cameron.
That's not remaining.
Mm-hmm. So what we would say there is that's not a factor. Because it doesn't divide into it evenly.
Yeah, then we should just have a work period on Tuesday.
I feel like there's more knowledge I need to impart from that, but that's the general gist of Tuesday's lesson.
Did you get minus 298?
I did.
Same. Wow, look at this go. Just put this on the.
Just put this. Just this. I'll still be yelled at because there's too many steps. Okay. So nothing is ever easy. That's not who we are as people. This is a really nice question to put on a quiz. We don't have a quiz in this unit. A test or an exam.
4 lessons and then.
Hint, hint, nudge, nudge.
Why would you say that?
I think it's funny. Like,
Try to do it. You told him to do it. You just took a picture of the person on your wall.
Shiv.
yeah, I just did that.
Okay, you guys ready? So, remainder theorem states that, we're going to substitute in, we're going to solve the divisor, and we're going to substitute it in, and we'll get the remainder. So, this way we're going to work backwards a little bit. So, we know that the remainder is negative 18. We know that this would be negative 4 if I solved it. So, that's going to equal... I'm leaving. I'm just solving now. I assume you guys are cool with the algebra. You guys are distracting.
Negative 10.
Yay. Perfect. Okay, so hint, hint, nudge, nudge, great question. Okay? Super easy to do, but you just got to know where that 18 goes, and you have to know to change the x's to a negative 4. Pretty straightforward. Okay, here we go. Word problems, always a fan favorite. Okay, the volume is given by this polynomial. What are the possible dimensions of the box in terms of x if the height is x plus 1?
Well, how would we be able to detect these things on the exam when there's like all the word problems together?
You're going to have to do it.
Not this guy.
I think they'll be pretty easy to differentiate.
If you show this to me, I would be able to tell you who this is from.
Okay, so if I said the volume was 100, and I told you, so the volume's 100, the width is 5, the height is 2, what's the length? Would you know how to do it?
Yeah.
Right? Don't write this down. This is just an example, right? So
Period. Okay.
it is 10 because we know the volume of a rectangular prism is length times height times width, right? So if you know what some of the factors are, if we just did this, it would be volume equals length times height times width. So we have 100 equals 5 times 2. Oh, I'm just moving stuff around. So we're going to have 100 equals 10L. That's a 10, not an R. And we would divide out the 10, divide out the 10, and L equals 10. So we know how to do it with numbers. You're going to do the exact same things, but this time we are going to just have polynomials in there. So if we know one of the dimensions is this, we got to find the other two. So we need to use synthetic division here. Okay? What? It's not that hard.
That's so.
Wow. That's more.
And yeah, bad handwriting versus bad face. What worse?
Okay.
You said
All
her
right.
face scared you.
Okay, so as your math teacher and as a human being, I feel a little attacked, okay? It's not. Because what do you say when I say we have to do synthetic division? What was the words out of your mouth? What did you say?
What did you say?
You said I don't want to. Okay. All right, synthetic division. So what am I dividing into what? So this is my divisor. That's my dividend. I'll give you a hint. Divisor is always going to be smaller than the dividend. Okay?
Well, are the length and the width the same? Is that what we're assuming?
We're going to just wait for the magic. Wait for the magic. Okay, so -1. So let's set this up. 1, 7, 14, 8. Bring the 1 down. Then what? The magic. The -1 times by the 1, which gives me -1, so it goes inside the box, and then I add those. Well, and I knew that because it told me that it was a dimension. So it has to go into it evenly. Yeah?
Do we just take the factors from the answer?
Wow.
Okay. So this is my remainder. This is my constant. This is my x. This is my x squared. So my quotient.
Oh, how would you know to factor that? You just
Okay, hang on a sec.
Because what else would you do?
I mean, yeah, I guess you see ax squared plus bx plus c, you're like factor.
Okay, so here's the thing though. How many dimensions does volume have? 3. So how many factors do we need? We have the 1 here, so we need 2 more. Can we find the factors of this? Yes, we can. Do we need to synthetically divide? No, we can just go ahead and factor this.
Yes.
Is it -1? Or I mean -4 and -2?
Well, we don't know what the actual volume is, so it just wants the factors, like it just wants the possible dimensions. So we know that the height is x plus 1. I'm going to say the width is x plus 4, and the length is x plus 2. It really doesn't matter if you switched these, because in volume, what are we doing? We're multiplying everything together, so it doesn't matter what order it is.
Okay, and if we multiply out, you should give us the...
Should give us the exact same thingy. And so the idea is these are factors. So if I multiply the height by the width by the length, you get right back to the volume. So that's what synthetic division does, is you have just fully factored a cubic function. Ta-da! So FYI, when we go to graph these, where are my x-intercepts?
Yeah. Okay.
-1, -4, -2. Oh yeah, we're going to graph these. That's it. That's all. That's all for today. And no, we can never have one good unit.